All right, you guys, let's try day 3 here. Okay, so far you've seen it where the numerator was larger than the denominator. You've seen it where the numerator is smaller than the denominator as far as the degree goes. Now what you're going to see is that the degree is the same as the denominator. The numerator and denominator are the same degree, perhaps if I say it that way without stuttering too much. I've gone ahead, because once again, the first thing I've always asked you to do in doing this is to factor it. Okay, brain and hand are not working. To factor it, then if possible simplify it. So I've gone ahead and I've factored it. And what you can see is that this thing is going to simplify. Right away, as soon as that cancels out, you know that you're going to have a removable discontinuity. You know you're going to have a hole. So you set what cancels equal to 0 and solve it. So -3 is the x value of the hole. I'm going to have to move that down. Okay, -3 is where the hole is. Okay, so we have to find out what the y value is. But to do that, you have to simplify it. So that's going to create the simplified form. You take what canceled and you fill it into the simplified form. So it would be -6 over -2 is 3. So the y value is 3. This is what you have for the simplified form. You next need to get the q of x plus r of x over d of x, so you can read out any asymptotes that you have. Do you have a horizontal or do you have an oblique? Dividing the bottom into the top, and you're welcome to do it with synthetic. Divide it in, and you get this. So in this case, it's 1 minus 4 over x plus 1. Q of x does not have a variable with it, so you're going to have a horizontal asymptote at 1 rather than at 0 that occurred in the other ones. So your horizontal asymptote is going to run along here at 0. Your vertical asymptote, and I should have changed color so I'm not graphing with blue just like that one. Your vertical asymptote is still red from your d of x. Set that equal to 0, and you get a vertical asymptote at x equals -1. And there it is right there. There's your vertical asymptote at -1. Okay? I can walk through the examples on the next page to show you what that looks like, but I'm just trying to walk you through that when the degrees equal each other, the degree of the numerator and the degree of the denominator, it's really not that big a deal. I don't think you guys need to memorize it. Just factor it, simplify it, find the q of x plus r of x over d of x. In this one, you're going to have a horizontal asymptote at 5. You're going to have a vertical asymptote at -3. And then you find your x-intercepts, y-intercepts, domain, and all that other stuff just like we have been. So here goes. First thing you have to do is factor it. So leading coefficient is 1, so that makes it easy. X plus 1, x plus 1. The denominator, let's see, I'm going to need an x minus 4, and it looks like an x plus 1. These cancel out. Straight away I know that I have a removable discontinuity. Take what cancels, set it equal to 0, the x value is -1. That's the factored form up here. Simplified form, that's x plus 1 over x minus 4. Sorry about the continued problems with the 4. There we go. Okay. To find the y value, take this and fill it in the simplified form. I get -1 plus 1 over -1 minus 4, so that's 0 over -5. Same problem with the 4, I apologize, which is worth 0. Now what you need to notice with this one, you guys, is look, -1, 0. That's an x-intercept. So it's almost looking like you don't have an x-intercept, but hold on, let's look at what happens when we actually get down to doing the x-intercept. Just keep that in mind when you're doing it. Okay. Vertical asymptote. Well, I need to write this, I need to divide this. So to help you with the division, what's up top is 1 and 1, and you're going to divide by a 4. So drop the 1, 4, 5. So your q of x is 1 plus your remainder over what you divided by. Hey, caramba. 4. Okay. Your vertical asymptote, you look at your d of x, set it equal to 0, and you get x equals 4. There's your vertical asymptote. Your q of x does not have a variable with it, so if you graphed y is equal to 1, you'd see a horizontal line at 1. If it had a variable with it, once again, you'd see that it would be oblique, but it doesn't have a variable, so y is equal to 1 is horizontal. You don't have an oblique. X-intercept. My advice to you has been, set the simplified form equal to 0 and cross multiply. 0 equals, so maybe if I do it down here, then you might be able to look back up. 0 equals x plus 1, x minus 4, cross multiply, x plus 1 is equal to 0. Excuse me, x is equal to negative 1. But look at that. That's your hole. Okay, it doesn't have an x-intercept. Y-intercept, let x be 0, and you get negative a quarter. You could also do it here in the simplified form, negative a quarter. Domain. X can't be negative 1 and 4. It's also what was your original denominator. X cannot be 4 and negative 1. Range. You can't be the y value of the hole, and you can't be the horizontal asymptote. So y cannot be 0 and 1. Okay, factor this one. So the top one looks like x minus 3, x plus 2. And this one, x plus 1, x plus 3. So this is a case where nothing cancels, so you do not have a removable discontinuity. You're going to divide the bottom into the top. Well, you can't do synthetic division with that. You have to do long division. So x squared plus 4x plus 3 being divided into x squared minus x minus 6. It's going to go in one time. 1 times all that is x squared plus 4x plus 3. Then you have to change the signs on everybody. And you got minus 5x minus 9. The degree of this is less than the degree of what you're dividing by, so all of that is your remainder. There's no simplified form, so that's going to be 1 plus a negative 5x minus 9 over, and you can leave it factored, you could leave it in its original form like this. I'm going to leave it factored because I think it's actually easier to do when it comes to finding these pieces. You look at your d of x to find any asymptotes. You're looking at this. You set this equal to 0, just the denominator. X plus 1 is equal to 0. X plus 3 is equal to 0. So x equals negative 1 and negative 3 is going to be your vertical asymptotes. You have a horizontal asymptote at 1. You don't have an oblique. Your vertical x-intercept, set this equal to 0. There's no simplified form, so this is what you got. Again, you're doing that because when you have an x-intercept, your y value is 0. So this is like y equals, so you're letting that be 0. So I'm setting it equal to 0, cross multiplying, 0 equals the numerator. Your x-intercepts every single time, you guys, has come from the numerator. I don't know if you've noticed that. In this case, it doesn't again because it's a hole at negative 1. So here, your x-intercepts are going to be 3 and negative 2. Y-intercept, let x be 0. So all this goes away, and you get negative 2. Domain, x cannot be, in this case, your two vertical asymptotes. Negative 1, negative 3. Y cannot be 1. Because that's your horizontal asymptote. Okay, so that should do it.